Okay guys, let's have the second demo, continuing with our first demo. Okay, so again we start with US WAN topology, layer 3 or layer 1. My first question is, which plan are you dealing with? So it comes back with the correct plan file that we are working with. Okay. Then I was asking, did anything change since last time when we did the demo, and he compared what we have with before and concluded nothing changed, still the same. Okay, did all the comparison, that's fine, nothing changed. And the canvas, the topology looks the same. So my first question is, if the traffic in this network grow by 25% next year, which node or link will break first? Okay, he's done a bunch of works, taking consideration from the MCP server, and he comes back with, this is important, yeah, that we know which plan we are working with. He says, well, the first one that's gonna break is New York and Washington, DC. So this link. So baseline today is already 85% loaded. If you grow 25%, that would be 170%, 107% overloaded. It will break first. And then he also highlighted what the other two might go across 80% of headroom. So it also gave a explanation on the layer 1. So this layer 3 hop mapped to New York, Washington, DC fiber span, 400 kilometers, 2 milliseconds. The next hop south, Washington, DC to Miami. At only 19% baseline stays. So the bottleneck is router port capacity on New York and Washington, DC, not fiber. That's good insight. Okay. Then I ask, who is using the link between CR2 Washington, DC and CR1 New York? This is what actually gave me this link. So he checked the MCP and checked all the demand metrics and comes back on which demand, so which peer-to-peer traffic between the routers are taking most of the traffic. So it turned out to be the edge router between Washington, DC and New York. That's almost 25% of that traffic. So nice. Interesting, that I haven't read. So by source and by destination. Good. You can tell me the story to the customer. This trunk is the IGP shortest path from every southern ER heading towards every northern, midwest, west coast ER. Half of the load is just one single flow. Okay. Washington DC alone contribute 58% link. There's no ECMP relief. Okay. You're already thinking about the solutions. That's not what I want to ask. I say, okay, is this the busiest link in terms of number of demands across the whole backbone? So he goes on and check all the links for me. Okay, it comes back. So, New York and Washington D.C. is indeed has the most peer-to-peer traffic. I mean, when I say peer-to-peer traffic, not peer-to-peer download. Okay, it's really the node, so router to router traffic. So there's 14 of them between New York and Washington D.C. Between New York and Chicago, it's the second most demand went traffic. Good. This is my next thing that I don't care for now. Then we move on. So it also says why this link is the most basic one. Okay. Now, I ask a double question. I said, so consider traffic is going to grow 25% next year, and the fiber were to go down between New York City and Washington D.C. This link, fiber cut. What will be the situation? Paint a canvas to illustrate this. So he did a bunch of things. Canvas is painted. We will see straight away. What shows lead cut out the headline. The East Coast spine splits. 4 trunks breach 100%. 1 is severe. Okay. We will see on the graphic. It'll be easier to see. Okay. So the graphic I already have. Here. So this is today's baseline, that where we see that Washington DC and New York already have 86%, and these two links are pretty high. Then if we grow the traffic by 25%, that will be the result. So this link is going to go to 81%, this one is 107. And if we were to cut this link without taking consideration of the 25% growth, it means Washington DC and Kentucky will go over the link capacity. Okay? But if we combine the two cases, 25% growth plus fiber cut total, bang, then we have a really bad situation. You can see between Washington DC and Kentucky, Chicago, I mean, mainly all of three will have problems. That's not good. So now I ask a pretty a stupid question. I say, so what is the least cost solution on this problem? Okay, considering Sarah Paine argument framework. So I will tell you what is Sarah Paine. Sarah Paine, she's a professor at the US Navy School, and when she teach things, she always asks the student to come up with their argument, main argument, second best argument. Okay, second best argument as a counter argument, then come at the end with a rebuttal argument. So that's what the AI is doing now. He says, argument, you can read it. The pure SRTE policy steer Washington using an elephant via Washington D.C. Atlanta is least cost fix. Zero capex, thin line of config deployable in 1 minute window. Okay. Counterpart. SRT is a band-aid on level 1 single point of value. The real least cost fix is buying a diverse 100 gig wavelengths on a non-correlated East Coast fiber pass. Okay. Then the rebuttal is, but prior answer are skipping the cheapest move. Just retune the ISS metric on Washington DC to Atlanta, so that Washington DC, New York, Washington DC, Atlanta, New York are equal cost pass. Okay, no SRTE, no fiber procurement, pure IGP arithmetic. So I don't want to go through all of this, but you can stop the video and check. Now, it's the summary. We can implement things. Okay, I said okay. Implement this rebuttal thesis and show me virtually. So he went on and tried to implement this in the model. Bang, bang, bang. And hit a bug. And the rebuttal failed, failed. Two reasons, both visible in Canvas's diagnosis section. Okay. Then plan geometry has no diverse East Coast because the US WAN. Okay. WAE simulator didn't produce 50-50 ECMP even at equal metric. It tends to choose the alternate for most flow. This is a real-world ISIS phenomenon. Tie break is not random. Okay, that's interesting. We can dive in that later on. Updated verdict. So at the end of the day, he recommended the correct least cost answer is to upgrade the capacity from 2.5 gig to 10 gig. Okay. Now I ask, do you have an inventory tool in WAE? So I can precisely know how much this can cost me. And he comes back and saying, okay, we don't have an inventory tool. Okay, it's not yet even built. Okay, it's even talking about Cisco Commerce Workspace. We need to have an API to get all the costs. And this is an estimate, like a rough estimate, how much that's gonna cost. He also captured a bug, fine. So I asked him to check after you fix the bug, is it still the same analysis as before? Done that, fine. It's still the same. At the end, I ask, do we have a inventory API given this two API document that we have using WAE Design? This is the WAE Design APIs that you can get online, which I have indexed them in Cursor. Now he done a bunch of things and found that, yeah, we do have that one. So he will basically look at this, and this is basically what I'm gonna do next. So he will build a MCP tool for inventory within the WAE, and then we can calculate next time the precise cost on this. Okay, we'll stop for today.